Receiver operating characteristics, or ROC curves. You will almost assuredly see these on step probably 1, 2, and possibly 3. You will never need to calculate them. This takes you back to calculus, but ROC, receiving operating characteristic, and AUC, or area under the curve being that graphing out the sensitivity versus 1 minus specificity. So where you have a continuous variable and you're identifying a threshold that you're going to say is normal versus abnormal for a diagnostic test, then the number of false negatives, positives varies by that. And that's what this ROC curve tells you. If you had perfect discrimination, it would be completely to the left. In the top, you perfectly identify everybody. The line through this figure, as you're looking at it now, is an AUC, or area under the curve, of 0.5. There's no discrimination for sensitivity versus specificity. We consider an AUC of 0.7 to 0.8 acceptable and 0.81 to 0.9 as outstanding. And if you want to go to a hot link here, if you want to read some more about it, you're really interested, there's a nice reference. And an example from looking at PSA, or prostate-specific antigen, again, continuous variable, where's your cut point for whether or not you determine somebody potentially has prostate cancer, and you're going to move on to next steps, which are invasive. And so really thoughtful about where these cut points are. And you see in the figure again, sensitivity versus 1 minus specificity on the bottom. They've got the actual specificity on the top of this figure. Not usual that you'll see it presented this way. With various cut points for those different lines, the bottom line being any prostate cancer versus none, then comparing the prostate cancer for a Gleason grade of greater than or equal to 7 versus less than 7. And you see improved or increasing amount of area under that curve and better discrimination then as you're moving to the left for an ROC curve.